Hello, and welcome to the lecture on files and directories. Unix file and directory structure is hierarchical, like many operating systems, and this just shows where some of the hierarchy is and the structure. But I want to go to the next slide, which really shows some of the ones at ACAD. So at the top of the hierarchy for all Unix system is root or slash. So everything from there is then subdirectories of the root file system. You can see some dev we'll talk about in a later presentation with devices. Home and export are two that handle some of the R files. So export/home/public is where all of the faculty public directories exist. So export is under the root, and then under export is home, under home is public, and then there's Fry and Spiegel and Parson and all of the other faculty under public. Under root is also a home subdirectory, which has Kutztown and students, which is where all of our home directories are. The faculty and staff are under Kutztown. Your subdirectories are under students, your home directories. Another one that you'll use a lot is USR/USR. So there's a bin, and you'll see the bin couple places that are binary files. ETC or etc is some miscellaneous files. Include are your include libraries, include files for your programs. Lib are your libraries. SBin is super user binaries, and there's other directories, but you can see the hierarchical structure. What we're going to talk about related to files and directories in this lecture are a little bit about file names, the ls command and permissions, links, and then briefly archives. A couple things about file names. Everybody knows what a file name is all about. If I just do an ls, you can see the file names. File names are just entries in a directory structure that allows you to access actual blocks of data on disk. There are two different types of file names, absolute and relative. Absolute means that you're giving the entire file name from the root directory. And it starts with a slash, because if you remember, the top level of the hierarchy is root. So if I do /export/home/public/fry/csc252, that's an absolute file name or absolute directory name, because it starts with a slash and it is giving you the specific file name. If I cat another file in that directory, that's an absolute file name, starts with the slash and gives you this very specific file name. It's an absolute name for the file. Relative is the file name based on your current directory. So I'm currently in my home directory, home Kutztown Fry CSC252 files. So if I do an ls-l, and if I do a cat junk, don't know what's in there, it's a junk file. If I do cat junk, it's relative to the current directory. Two special directory names, I'll come back to tilde in a second. Two special directory names are dot and dot dot. Dot is current directory. So you are used to that with doing dot/a.out. So I can do cat dot/junk, and it's going to be the same as doing cat junk. Current directory. These are relative file names. It's based on the current directory. Two dots is the parent directory. So if I do an ls dot dot, it's going to list the files in the directory that's one up from this one in the hierarchy. And I was in the files subdirectory. You can see that there in this listing. If I do an ls space dot dot slash commands, ls dot dot slash commands, if my finger does what I want it to do, you can see I'm going up to my parent directory and then down to the command subdirectory in that one. Again, it's a relative directory because it's relative to my current directory. So if I do a cat dot dot slash commands slash file4, we'll see the contents of this file4 file that's in my CSC252/command subdirectory, but it's relative to my CSC252 files directory, which is where I am now. So relative versus absolute. Absolute starts with a slash and it's your actual specific file name from the root directory. And relative is based on current directory. Tilde is a shortcut. Tilde is a character that represents the home directory, your home directory. So if I do a CD back to my home directory and do an ls, you can see some of my subdirectories there. So I'm going to go back into CSC 252 files. Now, if I do an ls tilde slash CSC 311, what that's going to do is it's going to expand tilde to my home directory. So it's really going to do an ls on slash home slash kutztown slash fry slash CSC 311. So the tilde is a shortcut for your home directory and can be very useful if you're someplace else. Like in my public directory, I often use the tilde to look at files relative to my home directory. So the ls command is a command that you're used to using many times, but let's delve a little bit more into that. ls just gives me file names. A more common is L or AL. If we do an ls-al, you'll see ls-al. My fingers, you'll see the dot and dot dot directories. Those are actually directory entries. So this is the current directory. You can see the permissions and everything. And dot dot's the parent. So let's talk a little bit about this long output. And you can change the output depending on the parameters that you pass to the ls command. So the very first bit tells you the file type. If it's a D here for the dot, 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 you can see I have a couple more. D is directory. A hyphen is a regular file, which could represent a text file, a C++ program source code, a Java source code, but it's just a regular text file of some specific type. L stands for a link, and we'll talk about that in just a few minutes here. C and D are specific to devices, so we'll talk about those when we talk about disks and devices in a later lecture. S is for a socket, which is beyond the scope of this course. That's related to programming. And then name pipe is really more into a programming as well. We'll talk about pipes this semester in this course, but not really name pipes. Then in our listing, we have the permissions, which are 9 bits. There's groups of 3, so there's 3 bits. The next 3 bits, bits 2, 3, and 4, related to the owner of the file and what permissions the owner has. The next 3 bits are related to the group owner of the file. And then the last 3 bits are related to other or the world or everyone. So you can look at these and see that I don't really have very many permissions granted to the group or other. You can see here test 0h. The owner, which is this row right here, Fry, has read and write, and the group, CSIT_faculty, has read and write permissions, but other, the world, or you, don't have any permissions to this file. So for a file, let's talk a little bit about those permissions. For a file, read, you can read the file, do a more or less cat, look at it. Write means you can edit the file. Execute means you can execute the file if it's an executable file like a program or a bash script. If it's a directory, R means you can read the directory, which means you can do like an ls command on it to see the directory contents. R means you can alter the directory contents, so you can add and delete files to the directory. And execute means you can execute the directory, which for directories means you can do a cd command to the directory. So if I create a directory, we'll call it temp1, and we look at that, by default, it's going to have read, write, execute for the owner. But if I would do change that execute permission, so let's talk about how we change permissions. To change a permission, you can either do it numerically or with letters. So to do it numerically, you have to equate numbers to the different permissions. And for that, R is 4, read is 4, write is 2, and execute is 1. And then you add them together to get what you need. So if I want to give the group read and write permission to a file, then what I can do, and I also want read and write. So I want read and write. Read is 4, write is 2, so that would be 6. I want the group to have read and write, and I want everybody else to not have any permission. So we'll do test1a. And now if I do an ls-al, we'll see that test1a now, I have read and write, but the group also has read and write. You can do it numerically. Again, read is 4, write is 2, execute is 1, and you add those together and form a 3-digit value, where the first digit is permissions for the owner, the second digit is permissions for the group, and the third digit is permissions for everybody else. You can also do it with letters, and you have to specify what you want to add or delete and to whom. And there's 3 letters for to whom. So the first grouping for the owner of the file, it's U for user. For the second group of permissions, it's G for group, and the last is O for other. And then you can do plus to add permissions or minus to remove permissions. And then you just do RW or X. So if I want to take write permission away to test 1A, we can see what we have. It's read write for user, for the owner and the group. If I do a change mod G for group minus write. So I want to take away the group's write permission. So now when I look at that LS, you can see that I still have read and write as the owner, but the group now just has read. If I want to add permissions, I could do like a change mod. I want to do user and group, and I want to add execute. So now what permissions will I have? Think about it. I added execute, so the owner, will now have read, write, execute, and I added execute for the group, so group will have read and execute. So you can see read, write, execute for the owner, and read and execute for the group. If I want to take away those permissions, I can just do a -X, and now we're back to read and write for the owner and read for the group. Again, you can do it either numerically or with this letter combination. The next item in the ls command is this number right here, which depends, the value representation of it depends if it's a file or a directory. If it's a file, it's the number of links for the file, and we'll talk about that in a moment. If it's a directory, it's the number of subdirectories. So you can see most of my directories just have 2 subdirectories in them. If I look at my public directory, you will see that the turn-in directory there near the bottom has 9 subdirectories. And we'll look at that a little bit. Later on, we talk about one other item. Then we have the owner of the file, which for all of my files here is Fry, the group, which is CSIT_faculty for most of my files, the size of the file or directory, the modification time, and the name. You can change some of these. So if you want to see like the last time the file was accessed or when the file was created, the ls command, if you do a man on it, has a lot of options that you can specify for how this display is done when you do the ls command. When processes are run, or when files are executed, like bash scripts or programs, when you would run a.out, a program or a process is run with 2 different user IDs and 2 different group IDs. It's a real user ID and real group ID, and then the effective user ID and effective group ID. The real ID, the real user ID, real group ID is the owner or the group of the file. And then the real user ID and the real group ID is the user that ran the process. The effective user ID and effective group ID are the owner of the file. And most of the time, they're all going to be the same. So when I run a program, the real user ID and effective user ID is Fry, and the real group ID and effective group ID is CSIT_faculty. So the real ID is the user that executed that command or program, and effective is the owner. Most of the time, they are the same. But what if you want to have a program that has special permissions that you don't have? And the perfect example is our turn-in. So if I do look at that public directory, the turn-in subdirectory of my public directory, all of the files you're going to be submitting for homework during the summer would be in one of these subdirectories. But if we look at it, the owner, Fry, has read, write, execute for all of these. Nobody else has permissions. So if you wanted to copy your homework into one of these subdirectories, you wouldn't be able to do it. There's some special permissions. There's what's called a set UID and a set group ID, and they work the same. It's just set UID works with a user ID or user name, and the group is a group ID, but they work similar. 4,000. So we talked about when you're changing permissions, we talked about 3 numbers. If you precede those 3 numbers with a 4, then it's going to set the group, the user ID. If you precede it with a 2, it's going to set the group ID, or a 6 would set both. Or you could just do the +S. We talked about the RWX for read, write, execute. S is for the set user ID, set group ID. And then when you do an LS, you see this little S right here for the user. This is has a set user ID bit set for the turn-in command. See, it says RWS instead of RWX. That means the set UID bit is set. What that means is when you execute turn-in, the real user ID will be your user ID. And if that were the case, you wouldn't be able to copy files into any of these directories. But because the set UID bit is set, the effective user ID is Fry. And so when you run this program that I own, during the execution of the program, you have permission to these files. So that's what allows you to copy your homework into my subdirectories where you don't have permission. So the set UID and the set group ID change the effective user or group ID when a process is run, which then will give the user running that process special permissions to access resources they would not normally have access to. Another special permission bit is what's called the sticky bit. It's 1000 or +T, and it depends if it's a file or a directory. If it's a file, it means that it stays resident in memory. So if you run a file that has the sticky bit set, a process, then it's going to stay in memory even when you're done executing it. So if somebody else wants to run that same program, they would not have to take the time to load it into memory. So you'll see that a lot with programs that are run frequently, like maybe Apache or SSH, so that it doesn't have to reload into memory every time somebody runs it. The sticky bit on a directory, and you see that here with this +T, means that even if you have permissions to alter the directory contents and alter the files in that directory, only the owner of the file can delete the file from the directory. So it's a little bit more protection from deleting files. Sometimes using just these permission bits for the user group and other aren't enough. Let's say that you had a directory of files that maybe both the business office and HR needed access to for payroll or something. So if you have an HR group and a business office group, you can't give 2 groups ownership of a file. So what you could do is you could create a larger group with all those members, or you could do a little more fine-grained control with permissions with access control lists or ACLs. So ACLs give you, allow you to use a set of rules to specify more specific or more detailed permissions for files and resources. It is some extra overhead, so it will reduce some of the performance. So use them sparingly if they are enabled, and they must be enabled for each specific file system. Now, I mentioned links a while ago. When I said LS, we have this L, it meant it was a link. So a link is another entry in the file system for a file. And there's 2 different types of links. One's a hard link and one's a soft link. I'm just going to copy this test2 file to test3. So now what I've done, let's just look at this here. So what I've done here is test2 and test3, I copied them. So you can see they're the same size, but it doesn't mean they're the same file. They're 2 different files. They just have the same information in them because I did a copy. They're 2 different blocks of disk data on disk, and there's 2 different file entries. You can see this one test3 here. That means it's 1 link to it. Test2 has 2. but it's not going to be this test3 file that I just created. Hard link is just another directory entry, another listing for a file that points to the same block of data on disk as another file. So if I create a hard link, let's say, and you use the ln command, so ln for link, hard link, let's create a hard link to test2, and let's just call it test2 new. So now if we look at test2, you can see I have test2, which says there's 3 links to it, and test2 new says there's 3 links to it. Means there's actually 3 files. I know one is test2 and one is test2 new. I don't know what the other one is. I could use the find command. One of the other things that you should be doing for this lecture and this module is going through all of the file and directory commands on that command list sheet that's in module 1. It may be in module 0, in D2L. Those are all the commands you should be familiar with, and you can learn about them by using the man page, so MAN and then the command name, or Google searches, and play around with them in your account. 2 of them that are very helpful, besides the ones we've talked about with ELS and chmod, is grep and find. So I could use the find command to find the other links to that. I'm pretty sure it's in this directory. So what I can do is this special ls command with the -il. I stands for inode number. Every file has an inode number, and we'll talk more about inode numbers when we get to the system administration lecture. But it references the block location on disk for a file. So hard links will have the same inode number. So if I look at test2, inode is 10235684. And test3 new is 10235684. And test2 new is 10235684. So those 3, test2 new, and test3 new, all point to the same block of data on disk. If I do a cat of test2 and I do a cat test2 new, they're the same file. I don't know that because they have the same information, and I could create another file that has the same information in it. But I know it because of the ls-l. The ls-il has the same inode number. But they are all links. If I remove all of these links, so if I remove test3 new, then I got rid of that one of them. Now if I remove test2, which was the original, so now I don't have that, and you can see test2 new has 1 link. If I do a cat test2 new, it's still there. I can still access that file. Okay, I'm going to create the hard link test2 again, just so I have that back. Whoops, I did it backwards. Get rid of my pop-up here. So I'm just going to create that test2 back. Now a symbolic link is just another reference. It's kind of like an alias, another word for it, but it's not pointing to the same location on disk. It's like a C also. So if I do ln-s for soft link or symbolic link, and I want to do it to test2, let's do it to test2 new, test2 soft. All right, so now you can see this test2 soft. It shows you it's a link, because it is a soft link, and it has this arrow. So that's how you know it. So now if I cat test2 soft, and I cat test2 new, the one that it's pointing to, they have the same information. The difference, if you remember, we removed the original of a hard link, and I could still remove the original. I could still get to the file with the hard link. If I remove test2 new, and now I try to cat test2 soft, I get no such file or directory, because a soft link is just a directory pointing to another directory entry. It's not pointing to that block of data on disk. It's just pointing to a directory entry. So if you remove the original file with a soft link, you can no longer access that file. Hard links are two separate directory entries pointing to the same block of data on disk, so removing one will not affect the other. You can also, when I do an LS, instead of getting this, I can also specify that I want to follow the link to the target file. So if we do a man ls, there's a no D reference that you can specify. Is it the, there's a no D reference that you can specify. And you can see here it says dereference command line. Follow symbolic links listed on the command line. And that's -- dereference command line or --H. So if I do ls-l, then if I do an ls-l, let's just do test to lower it down here. Up here you can see some of these soft links. If I do an ls-lh, so now you don't see those links, you see what they reference to, what they point to. And you'll notice up here, these were black in mine. It means they actually, what they point to no longer exist. So the test 2020 doesn't even list because it doesn't point to anything. So let's create another one, a soft link. Let's do our test 2 again. Create my soft link that doesn't exist anymore. Now if I do an ls test 2, a long listing, we can see that test 2 soft points to test 2. Now if I do an ls-hl test 2, you can see it actually just tells you the information about the permissions of the file, of the directory, of the file that it points to. So it dereferences that. Not all utilities can do dereferencing, so make sure you understand the utility and how it handles symbolic links. So understand the difference between hard links and symbolic links. Really quickly, just an overview of archives. Archives are a way to group similar objects. So if you have, let's say, some functions that are similar and you want to put them into one file to use in a variety of programs, you can do that with an archive. So if you have functions related to sorting, and you have a find min and a find max and a swap and a sort function, you could put those in an archive. And to add files or append files or get a table of contents or delete a file, to work with an archive command, there's a lot of other options. It's the AR command, and you can do a man page on that to learn a little bit more about that. And an NM command will show you the symbol table. So it shows you a little bit more detail about what's in the archive than the table of contents. Symbol table is a little bit beyond the scope of this course. That's a programming languages or compiler discussion. But the NM command is related to archives. So if I go into, if I do a user live and look at some of the archives on this system, you can see some of these. If I do an ART user live RPC service, you can see it shows you all of the object files or functions that are in that archive or in that library. Another name for archives are static libraries. So you can, when you compile a program, you can use a static library as your library for those functions. You can also use what's called a shared library. An archive or a static library is actually, when you link, it actually pulls that library object code into your executable. And then when you load it and run that program and it gets loaded into memory, that executable which includes the archive or static library, gets loaded into memory as well. With a shared library, it's not linked as part of the executable. It's what's called a dynamic link. And so it doesn't load that shared library until runtime. It's not part of your executable file. So with shared libraries, your executable file size is a little bit smaller, but it may take a little bit longer to load into memory because it has to go find it. But where it does get some runtime performance increase is if you have a shared library that a lot of users are using. So let's say that everybody in class wrote a program and everybody used the same shared library. and then you all were executing it during class at about the same time, the first person that would run it would have to have the overhead and go find that library and load it into memory, but everybody else, it would already be loaded into memory. And so there would be a little bit less runtime performance degradation. It would be a little bit faster at runtime for a shared library. But that's a little bit high-level overview of static libraries and shared library differences. It's a little bit more, again, beyond the scope of this course. But at least you understand what archives are. And hopefully you have a little bit understanding about symbolic and hard links, permissions and access control lists, the ls command, and some file and directory information. Again, please be reviewing and understanding the file and directory commands on the command list sheet. And our next lecture will talk about some of the behind the scenes or the internals of how files and directories work.